So, but maybe it was good. I demonstrated some pitfalls, some things to watch out for. So here's what you have to do today. This is just, it says bottle analysis or bottle analysis part 1. It's water bottle rocket analysis part 1. I'm not going to bother with brightening this so you can see it because I'm going to be mostly working on the screen. But this is about these phases: water thrust phase and air thrust phase, and then the beginning of the coasting phase. So by that I mean in the very beginning, water shoots out the bottom, the rocket pushes the water down, water pushes the rocket up. And you can tell when that ends because then air starts to come out really fast and there's this puff of air where the air starts to hit the water. And then for a brief moment after that, there's just air coming out and pushing. The rocket pushes the air down, the air pushes the rocket up. And then that stops happening and you can't see it, but you can tell because the rocket stops speeding up. So I'll show you how to do video analysis and get data to go in all these bold spots. So I'll do this for some random person's rocket from the other class. And then after that, your task is to answer all these other questions. And you're going to need information like your rocket's total mass at the beginning of the water thrust phase. So the dry mass that you recorded, and then you're going to have to figure out the mass of the water. But that's pretty easy because a milliliter of water, does anybody know how much mass that has? A gram. So a kilogram of water is a liter of water. And so you can get the total mass, and then you can figure out all this stuff. And when you get to a number 11, that's the hard part. That's the one where we figure out how high somebody would actually be launched with 30 of these bottles hooked onto them, assuming that they were 190 pounds stuff. So first step, either go to Google Classroom or go to my website to the Rocket video folders, and find your video, but don't use this video. So these are the videos from the other class. I'm just going to randomly open one up. So ooh, I think this one might have been oh no, yeah, okay. So this was one where their cone fell off. So I won't use that as an example. Let's do this one instead. You can zoom in a little bit. They're in chronological order. They should be. So if you can remember if you were the first group or the second group or the third or the fourth or the fifth, then you can, kind of a fun sound, then you can decide whether this is yours. If this is yours, look at that number right there, 014454. And remember that, and then go to the other folder that says smaller sized videos and find that. It's this one, right? So I think this is it. I'm talking and not paying attention to myself. So if this is the same number and this is in the smaller ones, I'm going to download this. Don't download that original one. Also, when you download it, make sure it goes, you know where it's going. This one's going onto my desktop, and I'm going to call this 7.8 example. And then go to Logger Pro and insert it. Now, if you try to insert the original video, they're really, really, really long. I timed how long it took to insert one of those, and it was 6 minutes, 49 seconds. And I don't know that anybody in here has patience and faith in a computer to let it go and let that little thing spin for 6 minutes, 49 seconds without feeling like, should I restart it? So this one that I put in here, 7.8 example, it's going to be slow, but I'm guessing it'll be under 10 seconds, hopefully. Anybody else like to hold your breath while you're waiting for those things? No. Sometimes I do. I like to say, I bet I can hold my breath from here until the end. Okay, so on this piece of paper, the goal here is just to get 4 pieces of data. might be annoyed by the fact that this is sideways, but it's actually good because it allows us to work with a longer space and be more precise. I'm going to go back to the picture. So what I'm about to do is I'm going to do some stuff that's listed here, and then I'm going to get this information. Back to Logger Pro. First thing I'm going to do is right-click, set some movie options. One movie option is I'm going to override the frame rate. I don't know why it's not picking up the Samsung phone slow motion frame rate. Should be 240, so change that. The other is this one that says first VA point defines movie time 0. Click that. That way your time will start at 0 and it makes the math easier. Then set the scale. So go to the back of the classroom, get your rocket, put it on the launcher, and measure, click these 3 points. Measure this distance from here to the tip of your rocket. The 10-foot pole is not in these pictures. It's for the other video. It's in the other videos. It's on the GoPro and it's on the one on my phone. And those we'll use for the whole flight. This is just for the beginning stages. So let's just say I measured that, and I watched somebody measure it earlier. They measured from the floor up to the tip of their rocket, and it was actually 1.04 meters. So I don't know if that's what it is for this particular rocket, but that's going to be my scale. And now there's some distortion here. As this gets higher up, it's actually moving farther from the camera, but we're just going to ignore that. It's not a huge effect, and it doesn't really matter for what we're doing. So another thing that I could do to make life a little bit easier but also harder, but then I can make it easier again, is set the origin. So I click this tool, and I'm going to click right on the end of the rocket. And you can rotate this. So if you don't like the way the axis is set up, you can rotate it. You might even want to go through. All we're going to be doing on this is getting the vertical motion of the rocket. So I want it to really follow that yellow line. So maybe that's good. If I go back, it pretty much goes along the yellow line. Okay, so I've got that set up. And I can move the origin out of the way from time to time. In fact, I might do it now. There, I move the origin over. Because it's annoying. That yellow line is going to make it hard to click. Advance forward to the point where the rocket just begins to move. Okay, I need to go back. Now I'm going to use these little frame-by-frame ones. See the little puff that appeared? Maybe you can't, but it starts to move right there. And then now I'm going to start collecting data. And I'm going to collect until the water thrust phase is over. How am I going to know when the water thrust phase is over? There's a puff of air. And in the beginning, it moves so little, I can't even see. My blue dot is covering up the tip still, so I'm going to advance it another couple of frames. And this is not a super precise thing. You're not going to be graded on your precision, but try to click on the same point every time. So as I advance this, I'm just keeping an eye out on this water coming out the back. And as soon as I see a little puff of air, then I'm going to do one more click and I'm going to stop. If you see a puff of air, let me know. And if you go too far, you can figure out which data point that was. I don't think it's happened yet. Oh, right there. See that puff? Maybe you can't, but I can. So I'm going to collect one more point. There. Now you can definitely see it. All right, so I'm going to go over to my data here. Because, so when I see the puff, that was, I had just collected a data point. I had collected a data point, and it advanced to the next frame, but didn't collect data for that. So that first vision of it, I didn't actually collect data. So right now, when I just, the last point I hit, and it makes it look like it's too late, but I actually have the data over here on the left don't represent that last point right there. This little blue dot is the one that I clicked, and that's how it was when there was that initial puff. So here's what I've got. This is the time, and this says 0 because of that, because I did the movie option and I clicked right here. If not, it would be whatever the video time was. Yeah. Yes, I should. Let me do that. Well, let me not, and then I will. So this is the time. 6.7 hundredths of a second have elapsed, and according to this, because as you pointed out, I didn't move the origin back. It's moved. Has it moved 2.513 feet or meters or 3.173 meters? Do I look at the X or Y? X, because really in the real life, the Y is like the X on here, because this is going, it's turned sideways on our screen. So these are the numbers I want, but it should start at 0 here to make my life easier. So I'm going to go back to here, and I'm just going to click on my first blue dot, because I'm going to make the origin the place where it started. So I did a pretty good job. I clicked within 10 centimeters of where the first blue dot was, and now I can see it's gone 1.322 meters. So go into my sheet. I'm going to go ahead and write two things on there. Delta Y at the end of the thrust phase is 1.32 meters, and delta T is 0.067 meters. And I'm going to get a little bit more information, and I'm going to use this measure tool, which is kind of silly because this is the way I set my scale anyway, and go to there, and that says it's 1.061 meters. So here's what the starting height of the rocket's tip was what I just measured, but really we know that that's supposed to be 1.04. This is how far it's gone during water thrust. This is how much time it's taken. Now all this stuff can just be skipped. These are calculations to do later. This is the hardest one. Just want to keep reminding you of that. And now the air thrust phase. So I'm going to get this bold stuff done. The end of the thrust phase, beginning of the coasting phase. I want to know what that time is. I want to know what the velocity of the rocket is then. And I want to know what the position is then. So I've got to find those three things, and then I'm done collecting data. So I'm going to just keep clicking for a little while, and I want somebody to see if you can tell me when I have reached, and I'm going to move the origin out of the way again. Tell me when I have reached the end of the coasting phase. Oop, need this. Or sorry, the end of the thrust phase. Am I there yet? And how would you know?
Wait.
Look at the data table.
Yeah. There's a bunch of weird variations.
Yes.
Definitely reached it by now.
Yes. So you're looking at the X velocity, right?
See when it starts
Yeah, there's a lot of inaccuracy because this is really small, and I'm only like a human, and I can only click so accurately. We used to have an app where you could zoom in, and it was awesome, but we didn't pay for the app this year, so no zooming in this year. So it's just an estimate here. So if you look, the velocity gets faster and faster and faster, and here it's slower. I'd say if somewhere in here. You can just use your judgment, but I think somewhere in here is kind of where the rocket really reached the maximum. You could transfer this to a spreadsheet, and you can maybe average each of these three together, but just eyeball it. So looking at this, I'm going to go back and set my origin again to the first one. And now I can get my information. So the end of the thrusting phase is what time? Let's just say it's right here. 0.087, so 87.8 thousandth of a second. And the speed, maximum speed, about 43. It says velocity, but speed. And then the delta y would be what? Well, no, because we're in sideways world. Yeah, it would be this. So it's x on here, but it's really y. And it wouldn't be negative. It should be positive. So yeah, I'm going to write that down. 0.08. Just going to call it, well, I'll write all the gruesome decimals. And the speed is 42 I'm just going to call that 43. And delta y is 2.27. So this is, I'd be done with everything that needs to be calculated today. So this is how long it took, not even a tenth of a second to reach the end of thrust. This is how fast it was going at that point. It just started slowing down, coasting, going upward. This is how far it had traveled at that point. And everything else you can figure out from the data that are here, like this. When it says y position at the beginning of the coasting phase, it's not the same as the y displacement. Does anybody know what the y position would be? This tells us how far the rocket's moved upward. If we want to know where it actually is, what do we need to add to that? Yeah, so this 1.0, it started from 1.04 meters from the ground. So you add that onto this, and that'll give you the height at this point. The other stuff I think you can figure out as you go, but the main thing is to get the bold stuff done today.